Alright guys, so I have a fun science fair project for you guys. We're going to be testing whether what flight pattern gives you the furthest distance with the glider. So you either keep trying to conserve your altitude as much as possible, so you're going to be flying slow and like eventually touch the ground, or if you trade your altitude for speed and use that speed to carry you. So we're going to be testing which one goes farther.
Yeah. So this is what I did for my science fair project. It was a lot of fun, and it was good because I didn't get like stuck with doing something that I really didn't like. Yeah. So most like RC stuff. If you're doing it for a science fair project, you have to limit it to one variable. I mean, there's a
or as few variables as possible.
There's a ton of different stuff. You'd probably have to have a wind tunnel to get most of the stuff. So we really didn't want to make one. So this is like one of the only things we can do. And I really want to do something with RC because it's fun.
Yeah. So I don't know. And yeah, there's not too many variables other than like user air, which isn't too big, and wind, and it's not very windy today. But yeah, this is an awesome RC science project that anyone can do. The plane that we're using, we got plans for it from Flight Test. This is actually the speed build kit. So what they do is they just laser cut the foam board that it's cut out of, and you just fold it and glue it as the instructions like on YouTube instructs. And yeah.
And instead of being like really annoying to build, like sometimes if you just build them out of normal foam board without any plans, it can be kind of annoying.
And like having to cut it yourself.
We've done that, but I mean, when you get a speed built, and this one was super easy. Like it's literally like building Legos.
Yeah, so this one's I don't know, if you're looking to do this one's called the FT Soarer. It's I don't know, just the basic glider that they have, and yeah. Let's go fly. Alright, so the procedure is we're gonna do 3 tests of each flight path. So we're gonna start off keeping our altitude, seeing how far we can go. Ryan, he's gonna throw it and stop at that cone. He's gonna try to throw it as consistently as possible so we get good data. And then after we throw it, we're gonna measure how far it goes.
And then the other 3 are going low and getting like a ton of speed, and then just gliding about this off the ground.
Yep.
So.
And we're gonna mark where the plane lands with some more cones. All right, I'm gonna check some close surfaces. Okay, yeah. Ready, set, throw.
This is staying at 5.
All right.
Okay, and also we're gonna mark the front of the plane.
Alright, so now we're going to do the low altitude flying. It's getting a little dark, but let's do it. There we go. Ready? Alright, so from the experiment we learned that the airplane that conserves its altitude, alright, so it doesn't trade a lot of its altitude for speed, will end up going the furthest. Now why is this? So you'd expect that both planes would go the same distance. So instead of like you either trade your altitude, you either don't go very fast but stay in the air a long time. So 2t and v. So stay in the air a long time, don't go very fast. Alright, you'd expect that to be equal to, alright, you go very fast, but you don't stay in the air a long time. So that would be you trade your altitude for speed. Alright? But the problem with this is you're not taking into account drag. This isn't a perfect world, so we have drag. But the equation for drag is, okay, so drag equals some constants, is p times, what was it? A times v squared over 2. Alright, so the most important thing about this equation is v squared. It's squared, alright? So drag is going to disproportionately increase to the amount of velocity, increase. So if we're trying to go as far as possible, we're going to try to keep velocity as low as possible to minimize drag. So this should become clear of why the airplane that tries to maintain its altitude goes furthest, because its speed is a lot lower than the one its velocity is a lot lower than the one who that trades its altitude for velocity, because it's trading its altitude for velocity, so velocity is going to be higher. So the one that is conserving its altitude is going to have a lot less drag, and that's why it goes farther. So I don't know, I thought this was a really cool science project. I had a lot of fun doing it. The cool thing about it is you have a really cool glider to play with when you're done, so that's always a plus. I hope this video made sense. If you have any questions, leave a comment down below, and see ya. So I don't know, I thought